Have you ever wondered how drones are reshaping the way we grow our food? Drones in agriculture are doing way more than just taking aerial photos. They're revolutionizing crop monitoring, precision farming, and even livestock management. Imagine using drone technology to predict yields and make real-time adjustments in the field. Join us as we dive into 10 groundbreaking ways drones are transforming agriculture for farmers and food production worldwide. Enhanced crop monitoring and surveillance. Drones are revolutionizing crop monitoring, giving farmers an unprecedented view of their fields. Equipped with high-resolution cameras and advanced sensors, drones can map entire fields in one flight, revealing plant health, soil conditions, and growth patterns. This aerial perspective uncovers potential issues that might go unnoticed from the ground. Early detection is one of the key benefits. Drones with multispectral imaging can spot plant stress and nutrient deficiencies before they become visible to the human eye. Addressing these problems early helps maintain crop health and optimize yields. Pest management is also enhanced with drone surveillance. Farmers can quickly identify areas with unusual patches that may indicate pest infestations or disease and target treatments precisely. This reduces the need for widespread chemical use, protecting the environment and cutting costs. The real-time data drones empowers farmers to act promptly and make informed decisions. Over time, drone data contributes to long-term planning by tracking trends in soil health and crop productivity. This knowledge supports decisions about crop rotation, fertilization, and which crops to plant where. Drones have turned crop monitoring into an efficient, insightful process that improves farm sustainability and resilience. Precision agriculture and targeted treatments. Drones are revolutionizing precision agriculture by enabling targeted application of fertilizers, pesticides, and nutrients. With aerial imaging and multispectral sensors, drones assess plant health, soil conditions, and moisture levels down to the smallest sections of a field. This allows farmers to apply treatments only where needed, reducing waste and boosting efficiency. Variable rate applications become possible, directing specific amounts of resources to areas that need them most. Picture a drone flying across a field, identifying sections that require more water or nutrients, and applying them precisely. This method minimizes chemical use and environmental impact, making farming more sustainable and cost-effective. Targeted pest control is also enhanced, allowing farmers to treat pest-infested zones without spraying entire fields. This precision supports healthier crops and a safer environment. Another benefit is improved crop yield and quality. Drones help ensure plants get exactly what they need to thrive, maximizing growth and productivity. This targeted approach leads to better returns and a more resilient farming system. In essence, drones empower farmers with insights to treat only what's necessary, fostering an efficient and sustainable approach. Precision agriculture with drones sets a new standard for farming that prioritizes productivity and environmental care. Efficient irrigation management with thermal imaging. Drones equipped with thermal imaging cameras are transforming irrigation management by helping farmers monitor water distribution with precision. These drones detect areas where crops are under water stress, pinpointing exact spots that need attention. This allows farmers to adjust irrigation based on actual needs, conserving water and promoting healthier plants. Thermal imagery can reveal variations in soil moisture that aren't visible to the naked eye. By capturing these details, farmers avoid over- or underwatering, which can harm yield and soil health. Imagine knowing precisely which areas need hydration and tailoring a watering plan that maximizes growth, like giving crops a hydration checkup during each survey. This targeted approach is especially valuable in regions with limited water resources or those affected by climate change. Efficient water use is not only cost-effective, but crucial for sustainable farming. Drones make it possible to optimize water usage, helping farmers adapt to environmental challenges while preserving this essential resource. Thermal imaging also helps detect leaks or blockages in irrigation systems, allowing farmers to spot issues early and prevent water loss. Regular drone surveys ensure that irrigation systems run smoothly, reducing maintenance costs and keeping water distribution efficient. Drones with thermal imaging are revolutionizing irrigation by offering farmers deep insights into soil and water conditions. This technology conserves water, boosts crop health, and creates a smarter, more sustainable approach to farming. Soil and field analysis for healthier crops. Drones are revolutionizing soil and field analysis, providing farmers with precise data on soil composition, moisture, and fertility before planting begins. Equipped with multispectral and hyperspectral sensors, drones can quickly survey fields and create detailed soil maps that guide decisions from crop selection to fertilization. This proactive approach helps ensure healthier, more productive crops. Drone-assisted soil analysis reveals nutrient levels, pH balance, and soil structure, all critical for crop health. Imagine knowing exactly which areas of a field need more nitrogen or which parts suffer from poor drainage. With this knowledge, farmers can make targeted improvements to optimize growing conditions. Using drones supports sustainable farming by preventing over-fertilization. Excessive fertilizer use increases costs and harms soil health, but precise drone data allows farmers to apply the right amount of nutrients, reducing waste and promoting a balanced ecosystem. This means lower costs and better long-term soil health. Drone technology also aids in planning crop rotation and selecting suitable areas for new plant varieties. By matching crops with the best-suited soil, farmers can improve yields and reduce the risk of crop failure. This tailored approach maximizes productivity and enhances farm sustainability. In essence, drones provide farmers with actionable insights for smarter soil management. This leads to better yields, sustainable practices, and a more resilient approach to agriculture that benefits both farmers and the environment. Planting and seeding innovations. Drones equipped with seed pod launchers are transforming the seeding process by making it faster and more precise. This technology allows farmers to plant vast areas in a fraction of the time it would take manually, ensuring optimal seed placement for better germination rates. Drone planting also makes it easier to reach challenging areas like steep slopes or marshy fields. These drones hover above tough terrain and drop seeds directly into the soil, enabling farmers to expand planting operations into previously inaccessible areas. Beyond planting, drones monitor soil conditions in real time, using sensors to gather data on moisture, soil composition, and temperature. This adaptive approach ensures seeds are placed in the most favorable spots, optimizing field conditions for maximum growth. Drones reduce labor costs significantly compared to manual seeding or using heavy machinery. Completing tasks autonomously, they require minimal oversight, freeing farmers to focus on other important aspects of their operations. As drone technology advances, innovations such as planting diverse seed types and dispersing fertilizers simultaneously are becoming possible. This integrated process enhances productivity and supports sustainable farming by minimizing resource use. Drone-assisted planting is reshaping agriculture, promising a future of increased efficiency and limitless potential. Crop spraying and pest control. Drones are revolutionizing crop spraying by delivering targeted treatments directly to crops. Drone-based spraying applies pesticides, herbicides, and fertilizers precisely where needed, reducing overspraying and saving on chemicals. This method helps cut costs and limit environmental impact while optimizing resources. Picture a drone identifying and spraying only affected areas, whether it's weeds in one corner or a pest-infested patch. Equipped with sensors, drones detect trouble spots and apply treatments only to those sections, minimizing chemical use and exposure to surrounding crops. This targeted approach promotes safer practices and limits chemical drift, fostering a healthier ecosystem. Drones cover expansive fields in mere hours, allowing farmers to treat large areas with speed and precision. Traditional crop spraying methods can be labor-intensive, but drones manage even the largest fields efficiently. This time-saving technology frees farmers to focus on other important aspects of their operations. Sustainability is another key benefit of drone-assisted spraying. By reducing chemical volume, drones help protect ecosystems, water sources, and soil health, aligning with modern sustainable farming practices. As technology advances, drones equipped with thermal and multispectral sensors will enhance real-time plant health monitoring and targeted treatment applications. The future of crop spraying with drones promises precision, safety, and sustainability, an adaptive approach benefiting both farmers and the environment. Yield prediction and harvest management. Drones are transforming yield prediction, making farm planning more precise than ever. With advanced imaging and data analysis, drones estimate crop health, density, and potential yield long before harvest. This enables farmers to plan for harvests more accurately, from labor management to storage needs, ensuring a smoother, organized harvest season. Through aerial monitoring, farmers gain a comprehensive view of crop conditions. Drones assess plant height, density, and health, using this data to forecast yield and track growth trends. This allows farmers to monitor productivity in real time and make proactive decisions to optimize both quality and quantity. Early insights from drones also help determine the best timing for harvest. By monitoring crop maturity, farmers can ensure harvests align with peak ripeness, leading to better produce quality and market value. Knowing which field sections are ready for harvesting helps avoid premature or late harvesting, improving overall efficiency. Yield prediction technology supports logistics by informing expected crop volumes. Farmers can better plan labor, machinery, storage, and transportation, reducing bottlenecks during peak harvest. With these early estimates, harvest workflow becomes more streamlined. Drones' role in yield prediction and harvest management marks a shift toward data-driven, proactive farming. This enhances productivity and profitability while paving the way for more efficient, sustainable agricultural practices. Livestock monitoring and management. Drones are transforming livestock management by giving farmers a bird's-eye view of their herds. With aerial imaging, farmers can monitor large areas and locate animals quickly, saving hours that would otherwise be spent searching on foot or by vehicle. This is especially beneficial for large-scale farms or rugged terrains where tracking every animal is challenging. Thermal imaging technology allows drones to detect changes in body temperature, signaling illness or injury before visible symptoms appear. Early detection enables timely intervention, reducing illness spread and promoting herd health. Drones also provide insights into pasture conditions. By assessing grazing quality and availability, farmers can better manage rotation schedules and optimize feeding practices. This ensures animals have adequate food while supporting natural vegetation regrowth, balancing livestock needs with land sustainability. Additionally, drones enhance farm security by monitoring livestock for predators and intruders. Real-time surveillance helps farmers detect threats and respond promptly, which is especially valuable in remote areas. Incorporating drones into livestock management leads to more efficient, responsive animal care and land oversight. This technology ensures healthier herds, well-maintained pastures, and swift threat detection, making livestock management smarter, safer, and more sustainable. Field mapping and planning. Drones are transforming field mapping by providing farmers with high-resolution, comprehensive images of their land. These maps capture details on soil quality, moisture levels, and field health, enabling data-driven decisions on crop placement, soil treatment, and water distribution. With precise mapping, farmers can plan field activities to boost productivity and efficiency. Drones reveal soil variability, showing differences in texture, pH, and fertility across the field. This information allows farmers to create management zones and tailor their approach for each area. For instance, nutrient-poor sections can receive additional fertilization, while richer areas can support nutrient-demanding crops, optimizing fieldwork and enhancing yields. Field mapping aids planting by identifying optimal areas for specific crop types. Farmers can avoid low-lying, waterlogged zones or dry areas prone to drought, ensuring better crop placement and reducing risk. This planning supports improved crop growth and a more resilient harvest. Drones also enhance irrigation management by mapping moisture levels, guiding precise water application to where it's needed most. This prevents waste and crop stress, conserving water and improving hydration efficiency. By providing real-time, precise data, drones enable smarter, adaptive farming practices. From planting to irrigation, drones help turn every acre into a well-optimized asset for maximum growth and sustainability. Weather and climate monitoring for risk management. Drones equipped with weather monitoring sensors provide farmers with localized, up-to-the-minute data on temperature, humidity, wind patterns, and rainfall. This real-time weather data helps farmers make quick decisions to protect crops from sudden changes like high winds or temperature drops. Drones are becoming essential tools for proactive weather tracking and effective environmental management. Weather is a major risk factor in farming, making accurate forecasting crucial. Drones collect detailed data that helps farmers anticipate extreme conditions such as storms or droughts and take preventive measures. For example, detecting rising humidity and signs of an approaching storm can prompt adjustments to irrigation schedules, preventing overwatering and minimizing damage. The climate data gathered by drones also aids in long-term planning. Over time, patterns emerge that guide decisions on crop rotation, planting schedules, and choosing crops suited to specific fields. This adaptability strengthens farms against climate fluctuations and supports sustainable growth. Drones play a vital role in frost and drought management by monitoring temperature and soil moisture levels. Early alerts help farmers take action, covering crops to prevent frost damage or adjusting irrigation to mitigate drought stress. This proactive approach protects crops and maintains plant health. Field-specific weather data enables timely adjustments that reduce risk, improve yields, and support a more sustainable farm. Drones turn unpredictable weather into a manageable factor, enhancing farm productivity and resilience through precision and control. As we wrap up our journey through the world of agricultural drones, it's clear these machines are more than just a new tool. They're revolutionizing farming itself. From monitoring livestock to mapping fields, drones are paving the way for smarter, more sustainable agriculture. If you found this video informative, don't forget to like, share, and subscribe to InnoVision Tech. Hit that bell icon so you won't miss our next update. Until next time, keep exploring the innovations that shape our future.